Hi, seventh grade. It is Tuesday, May 5th, and we are going to talk about, well, I need to turn this over, don't I? Lesson 110 on a Tuesday. And it's got a big long title, Simple and Compound Interest and Successive Discounts. Successive discounts. So here on our first side, we're going to talk about simple and compound interest. Now, where this is banking, and so this is a great application of math in real life. So if you go into the bank, and let's say you've got $1,000 that you want to deposit into a savings account. Well, the bank is going to say, yes, we'd love to have your money, and we'll keep it in a savings account. And because you're letting us hold on to your money, we are going to reward you with interest. And let's say that they're going to give you 10% simple interest every year for as long as you have that money in the account. So what does that mean if it's simple interest? Now, most banks don't use simple interest, but we're going to have to deal with it with our homework some, and so let's just talk about how simple interest works. Now, 10% is way higher than what interest rates are. Their interest rates are very low. Most, I think, are less than 1% right now, but depending on what kind of account, savings account you open. But I'm making it easy for us. Let's talk about keeping our money in the bank for 3 years at 10% simple interest. Just will be easy to calculate. Now, what is 10% of $1,000? Well, 10% is 1/10, and 1/10 of $1,000 is $100. So let's go ahead and add $100 to our account. That is the interest we're going to earn by letting the bank hold on to our money. What do they do with our money? Well, they let other people borrow money if they want to buy a car or a boat or do some type of home improvement. And so they will charge interest for people to borrow money. And then they're paying us interest for us to keep our money in the bank. Now, so I'm going to add $100. And so at the end of year one, let's just put here Y1 for year one. At the end of year one, I've got $1,100 in the bank. Now, simple interest means every year the amount I earn is going to stay the same. That's why it's so simple. So adding another $100, I'm going to have $1,200 in the bank at the end of year two. And let's add another 100. And I'm going to have $1,300 in the bank at the end of year three. So that is simple interest. Now, how much total interest did I make? I made $300 over the 3 years. I only had $1,000, and now 3 years later, I've made $300 in interest. Now, is there a formula I can use for simple interest? There sure is. Simple interest is equal to your principal, that's your deposit, times your rate as a decimal, times T, how many years it's in the bank. So if I were to use this formula over here, instead of doing this big long chart here and keep adding and adding and adding, all I'm going to say is simple interest is equal to $1,000, the amount I put in, times my rate of interest, which was 0.1 as a decimal, 10% as a decimal, 0.1, and then the time is 3. And so if you were to use your, we can do this mentally. 3 times 1,000 is 3,000, and 3,000 times 1/10 is $300. So there is our formula for simple interest, PRT. Now, what is the difference between simple interest, where we just earn the same amount every year, 10% of the original deposit? What happens when we have compounded interest, okay? Now let's look over here at compounded interest. And this is the kind of interest that most banks have, and you will like this interest, and you'll see why. Okay, now I'm going to deposit the same amount of money, and it's going to be deposited at 10%, the same rate of interest, compounded. Now, at the and so what I'm going to do for the first year, I'm going to figure out what my interest is by taking what is 10% of 1,000. I'm going to add $100, and I'm going to have $1,100 in the bank. Well, that is exactly what I had over here, wasn't it? I had $1,100 at the end of year one. So let's put year one. So you're like, oh, what's the big deal? It's not any different. Oh, yes, it is. It's going to be different right now. And what happens is it's compounded. Instead of just adding $100 every year, I'm now going to take this higher balance in my account at the end of year one and take 10% of it. Okay. Well, what is 10% of $1,100? Well, 1/10, I'm just going to move the decimal point over, it's $110. And so now I'm going to add $110, and my new balance is $1,210. Okay, at the end of year 2, I now have $1,210, which is $10 more than I had with simple interest. Okay, let's compound it again, which means to find year 3 balance, I'm going to take 10% of year 2 balance. And so what's 10% of 1,210? Well, let's move the decimal point over one place. It's $121. So I'm going to add $121 here, and I get $1,331. And that is my final balance at the end of year 3. Now, compare that to what I had over here, $1,300 compared to $1,331. I made $31 extra keeping it in a compound interest account. And you may say, well, that's not much, but let me tell you, over 10 years, 20 years, 30 years, if you keep something in the bank for a long time, which is what you should do with investments, it's really, really going to pile up and be so much more profitable for you to use compound interest. Now, do I have a formula for that? You betcha, okay? And that is right here. Now, this one is different. This simple interest formula just gives me the interest. It doesn't tell me the final balance. It tells me how much interest I made. Over here, this formula gives, with compound interest, gives me the final balance at the end of my time period, okay? So this one gives me the balance, the full amount of money I have. This one just gives me the interest alone. So with the simple interest formula that I ask you for, the homework asks you for the balance, you're going to have to add the interest to the original deposit, okay? This with compound interest, it's going to give me the final balance of everything, including the interest. So let's go ahead and calculate that. I'm going to put it right under here. What's the balance at the end of 3 years when my principal is $1,000? Now, here's what I'm going to do. I'm going to take a 1 and add to it my rate of interest, which is 0.1, 10%. And I'm going to raise it. It's going to be an exponential equation. I'm going to raise it to the number of years it's in the bank. Let's do it for 3 years. And so this is going to be 1,000 times 1.01 cubed. 1.01 cubed. All right. Now, so really, no, it's not 0.01. I'm so sorry. It's 1.10. It's 1.1. It gives you basically this is going to be 110%. Okay, I had 101%. So what happens is every year your new balance is 110% of what it was before. This is basically an increase in percent problem. My increase is 10%, so my new amount is 110% of what I started with. And so I'm multiplying by 110% every year. Now, this with the exponential form here, you could multiply 1.1 times 1.1 times 1.1 and then multiply that by 1,000. But I told you today you could use your calculator. So what I'm going to do is I'm going to go ahead and share my screen with my phone. Okay, so let's hope this is going to work. I'm going to share it with my phone. And let me go ahead and pull that up. And here we go. Okay. Now, I'm going to stop mirroring. Boom. And I'm going to go to my camera. Okay. Now, I have here the TI-30X2. The TI-30X2. I'm sorry, there's a little reflection there. The TI-30X2, which is the one that you were supposed to get. And if you have a different one, that's okay. But let's go ahead and turn it on. The on key is down here in the bottom left. Okay, now let's multiply. We had an equation that started with 1,000. So I'm going to take 1,000, okay. You know what my problem is? My problem is I'm trying to see this through the camera. Okay, let's try that again. 1,000. Boom, boom, boom. Okay, now I'm going to go ahead and use multiply. I'm going to multiply it with my multiplication key. And then what was in the parentheses? It was 1 plus 0.1, so it was 1.1. Okay, now, how do I do raised to the third power with a calculator? Well, here over on the left side, you will see that it's called a carrot key. It looks like a little rooftop or upside down V. That means raised to, and let's do to the third power, 3 years. And so I have a deposit of $1,000. I'm going to multiply it by my exponential term, which is 1 plus the interest rate of 10%, or 0.1 is a decimal, so raised to the 1 point, multiply by 1.1 raised to the third power. Then go ahead and press enter or equals, and we should have our balance, 1,331. And that's exactly what we got before, wasn't it? So let me stop sharing here. And we're back. And here it is, 1,331, but we did it with our calculator, 1331. So there you go. Here are our two formulas. Simple interest is principal times rate times time, and my compound interest is the balance, the final balance in the bank is going to be the principal times 1 plus R, 1 plus the rate of interest raised to the T power. All righty, let's go to the back here and let's look at one more concept, and that is called a successive discount. I like to also call this the double discount problem, double discount or successive discount. Now, what if I have a dishwasher that's on sale at Lowe's for $400, but it's just not selling? And so Lowe's said, I'm going to go ahead and mark it off. I'm going to mark it off 25%. Now, normally we do an OCN box here, but these double discount or successive discount problems are going to be pretty easy to do without an OCN box. They're going to have easy numbers to calculate. So let's just go ahead and not use an OCN box on these. The book does, but we don't need to, because look how easy they're going to be. Well, 25% off. 25% as a fraction, of course, is 1/4. So let's take a fourth of $400. Well, we know what that is. A fourth of 400 is $100. So I'm going to take off $100 from the original price. And I have $300. Okay. That thing is still not selling. Nobody wants it. Okay, it's got a dent in it. So what I'm going to do, well, what Lowe's is going to do, is they're going to do a second discount of 10% off. So now the $300 item is going to be another 10% off. And so if it's 10% more off, 10% is 1/10. What's 1/10 of 300? We'll divide this by 10, knock off a 0. $30 is 1/10. And so I'm going to knock off another $30. And now it's on sale for $270. And that's how simple those are. Now here is the one thing you cannot do. If you have a double discount like this, you can't just add 25% and 10% together and say, I'm just going to mark 35% off of $400. It doesn't work that way, because the 25% off is of the 400. The 10% off is not of the 400. The 10% off is of the 300. And so you cannot add those together and apply them both to the original price. It doesn't work that way. You won't get the right answer. So you have to do it 2 steps. First, take off the first discount and get a new sale price. Then take off another percentage and get the second sale price. Okay. Now, let's go ahead and do our first homework problem together, and that is number 2, and it is a double discount or successive discount, and it's a shirt that's $24, and Hector, I think is his name, walks in, and it's a 25% off sale, and then he's got a 10% off coupon. And he's like, oh, wow, awesome. So he's thinking, oh, I can just add those 2 together. No, you can't do it. The 10% off is going to be off of the sale price, not off of the original price. And so we have to do it in 2 steps. First, what we're going to do is take 25% off the original price. So what is 25%? 1/4. What is 1/4 of 24? $6. So let's go ahead and take that $24 shirt and subtract $6. And now my shirt is $18. Okay. Now, I'm going to or Hector is now going to be able to apply his coupon. So let me go ahead and do this. This is $18 shirt. Now he said, okay, I want to buy this $18 shirt. I want to take off 10% more. Well, what is 10% of $18? Well, let's move the decimal point to the left 1 place. It's 1/10. We'll divide by 10, and I get $1.80. So we're going to mark off $1.80. So let's subtract $1.80 here, and I get a 0. I'm going to borrow here. 10 minus 8 is 2. 7 minus 1 is 6. $16.20 is the cost of the shirt after a double discount. $25 off gives me the sale price. Another 10% off of the sale price gives me the final price he's going to pay for the shirt when he leaves the store. Okay, now we're going to do a banking problem. Now, your calculator, I'm only going to allow you to use your calculator to do these problems from this lesson 110, okay? I know that you're at home, and I'm just going to ask you to be on your honor. Please just use the calculator for the calculator problems in the lesson, okay? And there is one today, and it's number 19. All right. Now, let's look at it. We have a $4,000 deposit in the bank. Oh, that's a nice big deposit. And it's 9% interest compounded annually. And then number 19 asks us, what is the total account value or the balance in my account in the bank at the end of, at the end of 3 years? Okay, so we want to calculate the 3-year balance in this savings account. So I'm going to use my formula. The balance in my account is going to be equal to the principal. Well, let me go ahead and just write it down. Principal times 1 plus the rate of interest raised to the number of years. Okay. Now, let's go ahead and put our principal down first. That's my deposit, $4,000. Okay. I'm going to do 1 plus my rate of interest as a decimal. Do not put this in as the number 9. The number 9 is 900%, okay? You have to write 9% as the decimal 0.09 or you're going to be in big trouble, okay? Now, the number of years I want it in the bank to see what my balance is 3 years. So 3 is my exponent, okay? So let's take 4,000. Let's multiply it by 1.09. I'm going to add 1 to 0.09, and I'm going to cube it. And I'm going to see what my answer is. Okay. Now, go ahead and get out your calculator. I'm not going to share my screen again. I'm going to talk you through it. Okay. I have $4,000, so enter in 4,000. All right. You see that? I'm entering in 4,000. Now, I'm going to hit the multiplication key. I'm going to multiply it by 1.09, okay? Now, what do I do to show that it's raised to the 3rd power? I use my caret key, all right? My caret key right there, raised to the 3rd power, raised to the 3rd power. Well, let's go ahead and press enter and see what we get. All right. I'm checking to see if I have it right. Oh, look at there. Now, I'm going to have to round that. I'm going to have to round that to the nearest dollar. So let's go ahead and do that. So I'm going to have $5,180.12. $5,180.12. I'm just checking our answer to make sure we are in good shape. And we are in great shape. We're in great shape. Okay, so there's my formula for compound interest. This is my double or successive discount. We'll hopefully have a simple interest problem on our next chapter, our next lesson. We are not doing the investigation. We are not doing the investigation. Okay, well, oh, omissions. Whoa, omissions. Okay, so let's omit. Let's see what we're going to omit. That's not 10 problems today. Sorry, guys. It's not 10 problems. All right, it's 1, 3, 4, 10, 15, and 18. Okay. 1, 3, 4, 10, 15, and 18. And don't forget, Khan Academy, due Friday night. I noticed a few of you have done that. It's on scientific notation and finding the slope of a line. Slope of a line. Remember, rise and run. If you rise and run to the right, it's going to be a positive slope. If you rise and run to the left, it's going to be a negative slope. Okay, so that's it for today. I will see you at Zoom, or I will see you, everybody for sure, tomorrow, Wednesday, with our next lesson. All right. So hope you have a great Tuesday, and I will talk to you soon. Bye-bye.